folks, this is homework number 7, problem number 1, and I did something like this in the lab as activity, I believe, number 3 of lab number 8. And I'm going to do that, but to create a geometry, I'm going to do it a different way that I did in the lab, in that activity. Now, it is a previous exam problem, so I have some breakdown of the marks the way it was marked. As you can see, there are no part marks here. So everything has to be done to get the marks for that particular uh, portion of the test. Now, this let's go through the problem. It's a cylinder that's inserted freely inside of that block, and what that means is that these are not, rigidly attached to each other or fastened to each other or welded to each other. We just take this pin and insert it symmetrically inside of that. Okay, and the end of this pin, the ends of this pin, these end surfaces are clamped, and we're given the entire thing an acceleration, an upward acceleration, 9.8 meter per second squared. uh, I'm sorry, 5g, 5 times 9.8. So imagine that this is a piece that's inside of a rocket, and the rocket takes off with an acceleration 5g, and these ends are, kind of fixed to the inside body of the rocket. Now you're supposed to use as many planes of symmetry as applicable. You have to decide how many planes of symmetry do we have here, and also use the appropriate elements. So the appropriate elements, I'm assuming that you're going to do solid elements for both. Some of you may decide to become adventurous and, for example, use shell for this bracket and beam for that. It's a bad idea. But if you do something that is correct, I'll mark it accordingly. However, it better be right. It just cannot be half, uh, yeah, half done job. All right. So let's go ahead now. Obviously, in this particular problem, think about there are two planes of symmetry. One is cutting it along the length in the vertical direction along the length of the cylinder, and then cutting the block this way. Okay. So let me go ahead and make this thing. This has to be done as an assembly because assembly, the entire thing is made out of steel. I think the activity that I did in lab 8 was actually, one was steel, the other one was aluminum, and the loading was completely different. Okay. All right. So let's go ahead and I'm going to start with the product file. Okay. And immediately save this thing, file, save management, save as. I have a folder here called desktop, not delete, homework number 7, problem number 1. So everything is going to go in there as a product. Okay, so insert a new part in there. Let me do the cylinder first. How about that? So let me call this thing properties cylinder. And the approach is that I'm going to make the entire thing and then cut it in the assembly with the saw. Okay, so this is a cylinder. Let's go make it. Let me see the dimensions here. Radius is 1. So on this plane, I will sketch a circle of radius 1. On purpose, I'm going to draw it centered at the origin because later on I want to use these cutting planes in order to cut it appropriately. So this diameter 2, radius 1. Okay, exit. And then we're going to symmetrically pad this thing by, I believe it's 10 inches. So pad in both direction means mirror accent, 5 inches, which means multiplied by 2 is going to be 10 inches long. Okay, so that takes care of this. And I'm going to go all the way to the top level, click on the floppy, there, click on the floppy, and it's going to save that cylinder in the same folder that the product is saved at. Then I'm going to insert the next piece, insert a new part in there, and I'm going to call this thing a block, properties block. and block. This is the instance name, and this is the part name, or Catia calls it part number, of course. Let's make it. So double click on the block and we go make it. So on this vertical plane, I will sketch. Please note that I'm on purpose doing this thing differently from how it was done in activity 8. So these are each, I believe, 3 inches long. Let's see now, 3 inches, yep. So this is 3, and this is 3. 3. Okay. Uh, why don't I also project that circle on it? Okay, exit. And then we pad it symmetrically, 1 inch, 1 inch in each direction, because the thickness was here too. Now, what I want to do is I want to draw a surface here at 45 degree and then cut it. Okay, so let's go ahead and do this. So on that plane, I will sketch. But this is a crazy way of doing it, but well, that's the way I want to do that. So I'm going to draw a line going from, let's say, here to, we're going to clean it up in a minute. So this point, control that point. I'm going to make it coincident. Okay. This angle, I'll make it 45 degrees between this and that. 45. Okay. And why don't I also do a mirror this thing on the other side? So mirror that line. Where's the mirror here? Mirror here. This is the mirror. Yeah, mirror this line with respect to that. Okay. Exit. Now I'm going to extrude this thing. I'm going to extrude this thing as a surface and then cut that block with that surface. Okay. So let's go to create a surface. I'm going to go to generative shape design. Where's shape? Generative shape design right there. And I'm going to extruding a surface. It's right there. Extrude. So this, of course, because it's mirrored. It's going to do it on both directions. And then let's go. Maybe mirror extend. Does it go all the way? Not yet. We can make it longer. Yeah, good. Good. Uh, yeah. Actually, keep all sub elements. Good. And then we're going to split that solid object, which I cannot do it here. Okay. I have to go to part design and use that to split, because this split, the saw here, only cuts surfaces. Okay. So let's go ahead to part design. Let's go to part design, mechanical design, part design. Okay. Get the saw. Here's a saw. Read it carefully. Splitting element is this. Flip that. And, oh, wait a minute. Unfortunately, it looks like when I flip this, yeah, so let me do the following. Cancel. Let's cancel that. I have to clean this up. Okay, so there, what I should do probably is to go to back to that block, that sketch. Let's delete this. Okay, exit. All right, good, good. So let me split it now. This is the splitting element. We keep the other side. We say okay. obviously it did not like what I was doing. So let's read this thing. A block does not cut the right across one okay, so let's obviously this pathway that I'm taking is a bad idea. Well, I can't get it to work. I mean, this can be fixed. It's just that I don't want to spend too much time on that. I'm going to do that a different way. So let's go back to that surface. Let's go back to that surface. I can delete it from here, right here. Delete this. I have to eat my words here. Okay, so why don't we think about it for a second. Why don't we do this thing differently? Okay, so let's go back to things like this happen and you just have to fix it. Let me mirror this on the other side, no problem. The thing that I erased, remember I erased it? Let me mirror it. This with respect to that. Very good. And let me close this. By closing, I mean close this sketch. I was trying to do it with surfaces. It can be done. It's just that it's not worth the time for me to do it right now. I suggest you do that. And why don't we pocket? Just pocket. Okay. And pocket. Let me see for a second. More. Okay. All right. There we are. Okay. There's more than one way to skin the cat on a test. You have to do it the way that gets you there anyway. So let's go ahead and apply material. Everything's made out of steel. Metal, steel on that assembly. Good. And now we're going to go and cut this thing with the saw in the assembly design right there. Now read this thing at the bottom left corner. It says use the plane to cut. So for example, I use this. All of these I want to be affected. No problem. It doesn't matter which side. And then I cut it that way. So another split with this vertical plane. All of these I want to be affected. There we are. And this is our assembly. Now, notice that there are no assembly constraints here. If I move these things apart, they're not going to go back to the original shape, original position, because I did not put any assembly constraints here. It's up to you whether you want to do that or not. I don't need it for this particular problem, so let's go ahead and do the rest of it. So we're going to go to analysis and simulation, generative structure analysis. Okay, let me change the rendering here. There. Well, I'll keep the mesh the way it is. Right-click mesh visualization. You can see that. There we are. You know how to refine the mesh in an assembly and stuff like that. I've done it twice already in both two activities in Lab 8, and you should be able to refine any one of these pieces or the meshes for any one of these pieces wherever you're asked to do that. Right-click, deactivate. Now, let's see now. What are the surface sliders? Surface sliders go on this face and that face, and that face and that face, that face. Good. And this end is clamped. This end is clamped right there. And the whole assembly is given an acceleration upward. So where's the acceleration here? Right there. Acceleration is a body force. So I select this body in the direction Z. So this is 0. This is going to be 5g. So why don't I make it 5 times 9.81? Okay, good, good. I say okay, and I have to give the same acceleration to this other piece. Everything is the same. Say okay. Now, if I run this thing, it's going to bomb out because there is no connection. There is no interaction between these two pieces. So I'm going to make a general analysis connection. So between the surface of this cylinder, and for the second component, I'm going to hide the cylinder and the surface of the hole, basically. And this is going to be let me read this thing for a second. Let me read this carefully. It says the block is symmetrically positioned, and it doesn't say anything about two being perfectly bonded together or welded together, etc. Uh, yeah, symmetrically positioned. It doesn't say they're stuck together. Okay, so it's going to be a contact. Where is the contact? There is a face-to-face, face-face connection property. This is the contact, and you select that connection that you created right there. See that? This is the connection that you created, and we say OK. And well, hopefully we didn't forget anything. Let's save our analysis. File, save management. The analysis goes in that same folder. Let's see, where is that folder? Do not delete videos. That's homework 8, problem 1. Okay, and let's run it. The cylinder is in hiding. It shouldn't bother you. That's okay. And that's pretty much it. So let's look at the deflection. Okay, and let's do a few things here. These elements that you see here, these are essentially the contact elements that are created. If I don't want to see it, I can double click on this and go on the selection. Just show me the cylinder and the block. Okay, you can see that it actually looks like that, because what you should realize is that because there is no friction, when this is accelerated up, it actually develops a gap between them because of the nature of the problem. Now, this is exaggerated a lot. So if you go there and say, you know what, I don't want to see, I want to see the real scale. Okay, so actually, if you want to see the real scale, go change the scale to 1, and you see that, yeah, you see that, yeah, it's not as bad as it looked like. Okay, and you look at the stress distribution. Once again, if you don't like this thing, go and change the scale here, scale of 1. There's nothing wrong with what we are seeing. It's just that the way the problem is, because there is no friction here, when this thing accelerates up, this actually slides more than trying to leave that cylinder. And change the rendering here. There we are. If you don't want to see the block, if you don't want to see the cylinder, just double click on it. Say, just show me the block, and it shows you the stress distribution inside of the block. So yeah, that's pretty much it. So good luck.